This competition is putting in front of kids real people that are real heroes, that are doing things that these kids really can do if they work hard. And they're starting to understand through their relationships with these adults that the world is an exciting place for people that think, for people that can create.
The new Cold War is education, and FIRST is a very powerful weapon in that battle. And it's a chance to get young people excited about the prospect of taking control of their lives and learning and getting some satisfaction out of doing things.
We learn about science and engineering, which is really what this is all about. We have a lot of fun. I know that.
We got to looking at the whole idea of how we can expand our activities with regard to getting young people excited about science and math, and this was a perfect vehicle.
In '96, myself, Mr. Burke, our teacher, and two other students gave a presentation to Motorola asking them, hey, we'd like to partner with you. We know you're a great engineering company. Here's this competition that's really exciting, and we could use your help.
The leadership of the team from Motorola has been a big, big plus. The way Scott has led the team and the way that he's taken what needs to be done and has looked at it from a standpoint of, well, these kids are kind of my peers, and he's given them full input and some of the responsibilities that the engineers have, and the kids have really stepped up and have seen that, hey, I can do some of these things, and I feel good about collaborating with people that are college degrees or engineers that do this for a living.
One thing I'm very proud of this year is the student involvement. They've developed the robot. I'd say they've done 70% of the work, which is extraordinary.
The engineers kept on telling us to keep it simple. A lot of the ideas that we had were very complex and would have allowed us to do multiple things. And we saw so many robots out there that did multiple things and very complex things. There were designs like Ricardo's tilt-a-wheel, which made the wheels tilt up like that and then back on when you got onto the puck. We saw designs like that, but they didn't work 100%. But the design we had was so simple, and right now we're refining the simplicity of it, that we do one thing, we do it very good, and that's getting on the puck.
Senior manager asked me to start a team, and I thought about it for a weekend, came back, and after I'd looked into some stuff about it, and said, sure, we'll try it. And it's been much more exciting and bigger than anything I thought it would be.
Everyone shares their ideas. The Motorolans help us. They give us their experience. We come in with like a fresh sense of what's going on and, kind of hopefully bring some fun into it. And so I think those two together, I think it makes it a really fun time. And I think that's why people come back every year, is because it's just a wonderful experience working with them and being with them.
Building a robot here, which takes, 10 or 20 people to build it, and it takes 6 or 7 weeks of solid effort. The magnitude of that is huge, and I don't think it's easy to understand it without going through it and realizing that there's so many things that are being accomplished that you don't even understand because someone else has that responsibility.
We have some just really amazing designs that we've come out with, and other teams have commented every year, at least for the last 3 years, at how interesting and unique our designs are.
And I see a lot of teams struggle, and they don't always have all the resources, but with everything that Motorola has given us, it really has given us an advantage. And I think it makes it a lot better time, because we know we are not going to be struggling for anything, and so we have to work for it, yes, but I think it's kind of a security that we'll be able to do and to try out our ideas as we want to.
got 5 pros, 2 cons. So it looks like really favorable with the 4-wheel drive. Treads, you got 4 cons and 3 pros, so treads is out. Big wheel, con, 4 against 2. Big wheel's out.
You really can't miss any meetings, otherwise then you miss quite a bit. One of your ideas might be discarded, and then you come back, you're like, wait a second, why did you get rid of my idea?
What we found with the students is they have great ideas, but they're often very difficult to implement. So we needed time to explain to them exactly what a valid strategy will be.
You got to consider what we're trying to do here, okay? We're lifting at the most, I think it is 5 pounds. 7 pounds.
Plus the weight.
Okay,
that's
that's
you
one
get a
ball.
maximum of 10, 15 pounds there. It's nothing.
That's 1 ball.
That's what we're lifting, but the motor would need to push the mechanism as well, so there's torque required there.
Oh, gee.
Or something.
It can be achieved.
The swing arm will perform 2 purposes. One is to lift it and to push it, to push the entire cart and the platform forward, so that when we have the front wheel on top of the puck, and we can swing arm again, and at the same time the back wheel will push forward. And the second round, the swing arm will lift basically the rear wheel onto the puck.
Right.
And then you're going to raise the wheel back up.
Right.
And then you're going to take that thing and drive it forward to
Right,
that wheel
with the rear
gets under
axle.
the puck.
Yeah.
Okay. So
There will be
have
a-
some slippery stuff.
No, there'll be just put a little roller at the front.
Yeah, because you can't have...
Okay, so you retract the wheel up so the roller's the supporting thing, and as you roll it forward, then you drop the wheel back down. Now you got traction on the puck. Okay.
All the robot specs have been finalized. We have finalized the locomotion system, how we're going to get on the puck, how we're going to score, and how we're going to hold our floppies. We decided on a 4-wheel drive system with a Z drive, a forklift to raise the container up, which our container is going to be a box with a lid and netting on the sides to hold in our floppies.
We have solder over there. Somebody find solder,
I got some solder.
We're tuning the wires because there was a bad connection. We're trying to reattach it to the motor.
This motor over here turns this gear here, and these monkey bars come down, pivot, lift up the robot maybe about 6 inches, and then we drive on the puck.
Drive it on?
Yeah. And then you have this other motor that's going to be here, that's going to open.
You know, give me a black tie wrap.
Lid
There's a tie wrap
on the
we
robot.
have back over here. Black tie wrap.
And then you got the arms in the front, which you already got going.
Ready to.
Okay.
All we need to do is finish the monkey. Yeah, that was weird. Get on the BS2, and you have to tell us the PWMs and aliases and what switch is using, and we're good to go.
Okay.
Thanks, Jared. Only problem is just a little bit of logic on the monkeys. All right. On Tuesday, I can guarantee you'll have a finished program. If you say no limit switches is hit, and they say reverse, I have to keep going until.
You don't want to have to go all the way to the end and come back.
No, I have to keep going until it's in the limit switch.
So ideally, you need to know when it's moving, and you know when it's moving when your goal is different than your.
So you might have to have another logic
You
variable.
need some other logic variable.
We just start all over. Here's gonna start over in the mix. Come on. Oh, you're killing it again.
Okay. Fuck over here and drive up. All right.
We're expected to leave the robot today when it's fully finished. So basically, if we have to stay here till 6, 7, 8 p.m., that's what we're going to have to do. Our robot is pretty much more than halfway done. And we're very close to the competition, so we're just trying to rush to get everything finished.
I want to make sure we all understand exactly where we're headed with this design. Okay, that way it'll help me go through this and explain exactly what you need to know. Questions? Any specific things that you would like me to clarify? How many motors we're using? Okay, I'll write that down. because of the very high current, it creates a tremendous amount of heat right at that point where the current is passing through this material. And so it burns the metal, and it burns it, and it melts together.
At the end of this week, by next Saturday for sure, but hopefully before that, we're going to actually start fabricating some of the parts in the model shop, especially for the base and the drive.
The priorities are going to be that we're going to be working on the base. We want to get the base going so that the drivers can start practicing.
Go.
You know, our driver Tony and Diana.
Diana ended up being one of the drivers because she set in her mind last year that she was going to be the driver, and she did. She tested out to be the best.
You see this robot out there that you know everybody spent weeks and weeks and weeks making, you know, I mean, there's people here who just, all they do is dream, eat, sleep the robot, and then when you know that you're the one driving it and you're the one who's actually putting it into action, it's the greatest feeling in the world.
We're assuming that we can have control of the lid. I think we're always going to have control of the lid.
You'll have control of the lid. Why don't you guys show how this is going to work then?
Prototype team. You guys did some work on Thursday. I want to hear the results because I know that you documented some of what you did. So you want to talk about it?
You were going to use the arm like you're in a pick up floppies like this and then put it in the container.
Right.
But then we figured that if the arm is making like a horizontal movement, it creates too much friction against the Velcro surface. So we designed something, or we tried to design something better that would get off the Velcro easier.
All the software and the computer control for the robot is on this board. And we'll interpret the signals that come from the human controls and use those to drive the motors and the sensors and anything we need to run the robot in a more sophisticated way than just with the raw controls.
This is what we figured out. These are going to be the top fees. This is going to be the gurney return because it's the only one that doesn't, or wait, no, yeah, this is going to be the gurney return. The reason that this is the goal grabber is because everything else goes up or down more so, and then this one, it might, you know, it just turns it on, turn it off, and then these are drive wheels and lift.
We're kind of in a critical situation because we only have a week left, and we still have a lot of things that we haven't tried at all. We haven't tried the arm yet at all that picks up the floppies. We got a lot of the parts made, but we still haven't had a chance to even prototype it or see how it's going to work out. So that's a problem. The lift, we've got the parts kind of made. We're just trying to get the last pieces made for it. We've had all the three main sections made, but the one end piece that attaches to this is still to be made, and we're struggling a little bit with it. The electrical board is mounted, but only not really the right way. We just kind of threw it on there. We got a lot of work to do to get the weight out. We're probably about 3 or 4 pounds overweight.
The only obstacles we've had is things going wrong with our robot that we've had to fix, and really late nights staying up and coming up with different ideas of different things to try. But that's the whole part of the learning process, and I think that's the thing that probably helps us the most is, you know, finding things wrong and trying to fix them, and that's probably the best thing out of it.
We need to inspire the entire population of the United States if we're going to fuel the interest in technology and science and drive us forward as a nation. So please take that away. It'll be one of the most important things you can do for me, and I'll treat that as a thank you for Motorola and all of us trying to sponsor this and make this happen here in the Midwest. So thank you for coming, thank you for your interest, and thank you all for being involved.
The students went out and designed a database that held every single match. It was 2 minutes long, and had the complete score. At a press of a button, you would enter in the team number, and up would come not only the videos, but a link. You'd click on that link, and it would take you to the picture of the robots. You knew right away what your opponent looked like. Well, this turned out to be not only an amazing feat for a student to design this, but it became extremely powerful at the regional competition.
We're going to ask you for your pick. If we have somebody in mind, the team in front of us chooses them, you have to come up with another number.
We already have 3. We have 3.
Right. Who's third? I don't know. Looks like we're in 5th place, and we should have at least 4 choices.
We predicted who would win each match, and we were 100% right. only team that has ever approached this type of opponent analysis. So they've seen from one small little idea to branch out into a much larger scheme that was very important to the success of the robot. We set 2 records. We got the best play of the day. We scored a perfect score, and which had never been done at that regional. We took home the most number of awards that any Motorola team has ever taken away from a competition. Just a phenomenal performance. We took 2nd place. It was a very good chance we could have had 1st. We did awesome.
This is our basic strategy, and it depends for this year because we have to work with another team, and which makes it kind of interesting this year. We're focusing our robot on getting on the puck pretty much. We have our 2 different ways of getting on the robot, and we also have two different ways of trying to get to the robot, our crab mode and tank mode. When we start off, our first goal is to go to the human player. Here's our robot right here. And so what we're going to do is we're going to drive right over here, and the human player is going to give the floppies to the robot. And from there, of course, our main goal is to get to the puck. And then from there, we're going to get onto the puck, and we have our 2 different ways. We have our gurney method, which is just ramming right into the puck and trying to get on. Or we have an arm, a grabber, which will grab onto the pole in the puck and will pull us up.
They're crunching together.
Yeah, every time they'd open one, they'd use one. Yeah. What we're basically trying to focus on is trying to figure out what team we're going to partner with in the finals if we get to pick someone at this point. So we're just trying to scout out the other teams and find out which team has the ability close to what we want, so we can have the best combination of abilities.
Okay, how are you guys on getting on the puck?
Any way you want, but we want to just dive on for once. We keep grabbing the pole. Everybody wants us to grab the pole. We want to go get 4, if it's okay with you. They always tell us, well, you guys are so good. Why don't you just grab the pole and hold the thing for us? And we catch ourselves with only 2 floppies or 3 floppies. And then they have like 7 or 8 in their basket, and they can't get it up their feet. And they mess up. All right,
where are we at?
Could we have one representative from team number 111, Motorola?
It's a nice award because it just means that we really did a good job on the robot. We think we do have a machine that is good quality and will hold together. We had a few little glitches at first, but I think overall it's a really strong machine and it holds together.
It was nothing like what I expected. I remember just walking into the gym and hardly knowing what to look at first because there was just so much going on. It was so exciting.
I think we're going to finish in the top 8. We have a high-score machine. It's a well-engineered machine. It's simple enough to where if anything goes wrong, we can fix it. The engineers are well-organized and got the kids ready to go with taking care of anything that needs to happen. And I think we showed that in Chicago.
I hope for the best. I hope we win, but I still think we're going to definitely get in the finals, definitely, and hopefully, and we'll see what goes from there. It's anybody's game.
The founder of First, Dean Kamen. Dean.
While you're out here working very hard, I'm going to be all over the place working very hard. You're working on this year's competition. I'm trying to make sure that we're going to grow as much next year as this year, so I'm going to be working very hard with all of our prospective new sponsors and team supporters And what really drives them to participate is watching you and seeing your enthusiasm and seeing your gracious professionalism.
The last two matches, our allies haven't come through for the moves that we've needed, but we're still in the top, and we should be able to qualify.
Going great. Going great. We feel real comfortable about where we are, where the robot's performing. Kids are all performing well, so everything's going great. We've only had 2 matches, qualifying matches, but overall really good.
We want to be part of the Sweet 16. That's where we want to be. If we're there, then we can choose our alliance, and then we can probably, I would very well, this team can win and go all the way. Hey, hey!
Another win.
Have you completed all of your matches, and now it's a matter of waiting to see who the top 16 are?
Correct. Yeah, if you look on our board over there, we have we've won 5 matches. We've just lost 1 match yesterday.
It was unfortunate we didn't get chose in the final 48, but we felt that being the highest finishing Motorola team, accomplishing all of the team objectives, and being just an incredible spirited team, and the kids learning and all of us learning part of the process was really worth it.
We can just get it started. We can put power on the motor to make it spin, or we can backspin to make the teeth minute. Do you see the screws? Yeah.
This match, somebody was pushing our lift down, so we weren't able to lift up. Because when you lift 8 feet, you triple your score. One robot, since they knew that they couldn't lift 8 feet in the air because their robot was malfunctioning, they decided to hold us down, which was actually a good strategy on their part.
We lost.
What happened?
Well,
sure.
We got stuck in our corner. We couldn't get out. So we were there a little bit longer than we wanted to be, and couldn't get out.
If we don't get in the top 8, I think some other teams will pick us. A lot of people have commented on how good our robot is, and they seem to like our robot. So hopefully we'll get picked by somebody else. That's our hope.
Team 45, and we pick 111.
Oh my God, my heart is racing so much right now. I can't believe we're getting this far. We are working so well as a team. The three teams, we're just like, I mean, we're all competing right now. Nobody's sitting out, nobody's sitting on the bench. We're all working together perfectly. We complement each other so well. This is just unbelievable how well it's going.
You can't put this many great engineers in one place with the energy of this many kids and not get this kind of reaction. It happens like this every year.
That was awesome. Oh, that was so good. We've never gotten this far yet. This is the first time that we've been able to win 2 out of the 3, and then we're going to go on. And it's great.
You got to bring everything down.
we got this far and we didn't win first place, but we did unbelievable. We had like the best matches. I can't say I'm disappointed in how I did because everything we did was just exactly what we wanted, and I can't wait for next year because we're going to come back and win it all.